All right, so one of the big things you always need to remember is with synthetic factoring, if you can do another method, use another method. But don't let problems trick you into thinking you can use another method. This problem often throws people off because they think they can just factor it like a quadratic, but that's only possible if this exponent is twice as big as the exponent with the middle exponent. And that's not the case here. So we have to use synthetic for this problem. So, like before, we need to go ahead and find our potential zeros, is what they're called. So, just a review of that, you do your p, so the factors of the last term over the factors of the first. So we'll do plus or minus factors of 6 are 1, 2, 3, and 6. Factors of 1 are just 1. So that means you have plus or minus 1, plus or minus 2, plus or minus 3, or positive negative 6. Now, another quick trick, remember, is to try out 1. If I put 1 in, that's where you just, so I'm trying 1. I just add or subtract the coefficients. If I get 0, great. If I don't, that means it doesn't work. So negative 12 means that 1 doesn't work, so that did not work. So I'm going to cross that one off. And I often try negative 1 next because that one's easy. If you remember my trick from the last video, I just changed the signs of the terms that have an x that's raised to an odd power. So this would be negative 1, positive 7, and then minus 6. And we're in luck, that gives us 0. So that means we didn't have to try any of these other ones over here. But if the negative 1 didn't work, we would start taking numbers off of our list and trying them. So let's go ahead and do our synthetic. So we have negative 1. Now we're skipping the x squared term, so I need to make sure I put a 0 in for x squared. We got negative 7 and negative 6, and I'll go ahead and do my synthetic. So drop down the 1. 1 times negative 1 is negative 1. We get negative 1. Negative 1 times negative 1 is positive 1, so we get negative 6. And then that will give us 6. When we multiply those together, you get 0. So, biggest thing people forget is the term in the box, so we need to make sure that's one of our factors. So we have x plus 1 again. And then we'll write these ones out as x squared minus x minus 6. And then the other thing they forget is that you can keep going. So if you see a quadratic or something higher than a quadratic, double check that to see if you can factor more. So this one's easy. Since it's x, just plain old x squared, we know it's x times x. Factors of 6 are 2 and 3. We're trying to get a negative 1. So I'll do a negative 3 and a positive 2. Something I didn't mention in the last video, but you can actually see what other factors would have worked. So we know negative 1 worked, and that's because of this one right here. Negative 2 actually would have worked as well. So we know negative 2 would have worked because of that factor. And then the last one that would have worked is positive 3. So you'll notice that not every single number on this list will work. Some of them will, and that's why it's kind of a guess and check method. You just keep going until you find the one that works. For this video, let's go ahead and just do a second example. So once again, before you start doing synthetic, just double check to see. Well, if I take out an x squared, I'd still have 2x plus 5. There's nothing I can take out of 7 and 5 to get a 2x plus 5. So I know I'm going to have to use synthetic. So, once again, just to practice, let's do our p over our q. So factors of 5 are 1 and 5 over factors of q, which are 1 and 2. So that means we have positive negative 1, positive negative 5. So I just divided by 1 for both of those numbers first. And now let's do positive negative 1 half and positive negative 5 halves. So we're going to go ahead and just plug numbers in. I'm going to use my quick tricks. So 1 won't work because 2 plus 5 plus 7 minus 5 does not equal 0, so that's a problem. Negative 1, if I switch the signs of the odd exponent once, I'd get negative 2 plus 5 minus 7 minus 5. Well, the 5s would cancel. That's definitely not going to be 0, which means we're going to have to start trying other numbers. So let's go ahead and try 5. times 5 cubed plus 5 times 5 squared plus 7 times 5 minus 5. Well, just looking at this, I actually made a mistake on even thinking I should have done 5, because that's going to be a pretty big positive number. The next one's going to be a pretty big positive number because that's 125. This one's going to be 250. It's going to be 35. All of those are really big positive numbers, and you're only subtracting 5. So that's definitely not going to work. So let's try negative 5. So 2 times negative 5 cubed plus 5 times negative 5 squared plus 7 times negative 5 minus 5. Well, this one would be negative 250, positive 125, negative 35, and a minus 5. That's also not going to get us because this, so that'd be negative 125 with these two. So I know that doesn't work, so I'm just going to keep trying. Let's try 1/2. So you see how this can be a bit of a process. And, you know, I don't remember which one is the right answer, so we're just going to keep going. So 1/2 cubed is an 1/8 times 2 is a 4th, so that's a 4th. And that's a 4th or 5/4. So we've got 6/4 so far. This is 7/2, and then minus 5. I'm going to go ahead and convert all those. So this would be 6/4 or 3/2 plus 7/2. That's 10/2, which is 5, and we're subtracting 5. So we know that's 0. We found it. After all that work, we found our number. So a little bit of a lengthy process. I'm going to go ahead and put the 1/2 in. I get 2. I get 5. I've got 7. I get negative 5. So drop down the 2. 2 times 1/2 is 1. This is 6. 6 times 1/2 is 3. That's 10. 10 times 1/2 is 5. And that's our 0. So don't forget the 1/2. So we're going to have x minus 1/2. And then we'll have 2x squared plus 6x plus 10. Now, before I do anything, I'm going to factor out my greatest common factor and put it in front of everything. So I've got a 2, and I still have the x minus 1/2. And we've got x squared plus 3x plus 5. So just a comment right here, this quadratic right here, there are no factors of 5 that add up to 3, so I know I'm done. However, one thing I want you to notice is there is a factor that has a 1/2 in it. We don't like that. We don't like fractions in our factors, so I'm going to go ahead and distribute the 2 in. So you get 2x minus 1 times x squared plus 3x plus 5, just so it's all integers as our final answer. And there you go.